Hey guys, my name is Achileshe Anichewe and welcome to Econ Asia, where I explain economics in the simplest way possible. I'd like to thank everybody who has subscribed to my channel. And if you're new to my channel, please subscribe to my channel. With that being said, let's get to it. Okay, so initially I was supposed to do part 2 of supply and demand, but due to what people asked me to do, I'm doing a video on differentiation, on the rules of differentiation. So, differentiation. Again, please bear with my handwriting. Sorry, that's differentiation. Okay, so the first rule we're going to look at is the power rule. Okay. So what the power rule simply states is that if you have an equation, y is equal to x to the power n. So to get the derivative of this, so dy dx, or you can also use y prime. Y prime also means the derivative. So dy dx is equal to, you multiply the power times the coefficient of the variable here. So this will be n times, the coefficient here is 1 times 1. So x, and the power reduces by 1, n minus 1. So you're simply multiplying the power times the coefficient, which is this, and the power is reducing by 1. That's all we're doing. Okay. So let's use numbers. So we're doing that. So keep that in mind. Let me put an equation that actually has numbers in it. So if we have y is equal to x to the power 2. So y prime, or dy dx, is equal to 2, which is the power, times the coefficient of 1 here is 1. Then x, the power reduces by 1, so 2 minus 1. So y prime is equal to 2 times 2. X, the power reduces by 1, so that's just 1. So x to the power 1 is just the same as x, so it's okay even if you don't put the 1 there. So this is the derivative of this function. So let me try to put up a different equation. I hope it's clear in that one. I'll be a bit slower on the next one. Okay. So if we have the equation y is equal to 3x squared. So y prime, again, which is just dy dx, which just represents the derivative of this, is we're going to multiply the power times the coefficient. So this is 2 times 3x. The power reduces by 1, so this is 2 minus 1. So y prime is equal to 2 times 3, that's 6. X, 2 minus 1 is just 1. So it's okay even if you don't put the 1 there. X to the power 1 is the same as 1. So this is 6x. So this is on the power rule. That's the power rule. We're simply multiplying the power times the coefficient, and the power is reducing by 1. Okay, so the next rule is the sum and difference rule. So let me just write that down. Sum and difference rule. So sum and difference rule. So with this rule, unlike the power rule where we only had one term or one function, this one we have more than one. We have more than one. So y, let's say the equation y is equal to 3x squared plus 4x to the power 3. So this is an example of an equation in the sum and difference rule. You've got 2 or more terms that are separated with a plus or a minus sign. But the differentiation is the same as with the power rule. So we'll still be multiplying the power times the coefficient, and the power will reduce by 1. Okay. Except we're going to be doing them separately. The sign in the middle will still maintain. So you can actually have more. You can even have, let's say, minus 2x to the power 4. So they're all independent terms that are brought together with different signs. So to differentiate this, to get dy dx, so dy dx is equal to, so remember, multiplying the power times the coefficient. So this is 2 times 3x, and remember the power reduces by 1. So to the power 2 minus 1, like that. The sign maintains, plus, so the power times the coefficient, 3 times 4x, and the power reduces by 1. So 3 minus. Then the last one, so minus the power times the coefficient. So that's 4 times 2x, the power reduces by 1. Like that. So that's what we've done here. We're simply multiplying the power times the coefficient and reduce the power by 1. That. The power with the coefficient and reduce the power by 1. The power with the coefficient and reduce the power by 1. That's all we are doing. So please, let's be together. Okay. So dy dx is equal to, we can now expand this. We can now deal with this. 2 times 3 is 6. Then x to the power 2 minus 1. So 2 minus 1 is just 1. So this is x to the power 1, like that. Plus 3 times 4 is 12. X, 3 minus 1 is 2. Minus 4 times 2 is 8. X, 4 minus 1 is 3. 3. So let me just rewrite this equation. So dy dx is equal to, so here we had 6 x to the power 1, which is just the same as x, plus 12 x to the power 2 minus 8 x to the power 3. I hope, okay, if my handwriting is too terrible, if you can't read my handwriting, I just hope you're getting what I'm saying. Okay, so this is how you differentiate using the product rule. Okay, so we're simply multiplying the power times the coefficient, and the power reduces by 1. So even though this looks like a lot of work, we're just simply doing that. That's all we're doing. So that is for the sum and difference. Okay, so next up we have the product rule. And please, the next things I'm going to say, I need you to pay extra attention. It's not French, it's still English. So please, let's stick together, okay? So with the product rule, you have an equation such as, in this form, y is equal to f of x times g of x. So this is the product rule. Remember, with the sum and difference rule, we had different functions being separated with a plus or a minus. But then with the product rule, they're being separated with a multiplication sign. So that's the dot, which is just the same as multiplication sign. So in order for you to find the derivative of this, an easy method that I use is, we have this function, and we also have this. We've got two functions here. So you let the first function equal to u. So let u be equal to the first function, which is this, and let v be equal to the second function. This is the method I normally use. Let the first function be equal to u, and the second function be equal to g. Okay, to be equal to v. So we've just separated them so it will be easy for us to get the derivative. So after doing this, now coming to the formula. So the formula of the product rule, differentiation of a product rule, is dy over dx is equal to u prime v plus u v prime. Please, I did not just speak French. It is still English. So remember, I said u prime is simply the same as dy dx. So in this case, instead of having dy dx, would have had y prime. So u prime is simply saying the derivative of this. So u prime in this case would be the same as du dx. But we're just saying u prime so that it's less congested. So that's u prime v plus u v prime. So this is the derivative of u times the v function, just the way it is, plus the u function times the derivative of v. Okay. So let's use numbers so that it makes sense. Okay, let me quickly rub this. Oh. I hope we're good so far. Hope these things are making sense. Okay, so now we come to an equation with actual numbers. Let's say we have y is equal to 2x squared, open bracket, 4x minus 1. So this is an example of an equation that we need the product group, because we've got 2. Remember, this bracket simply means this is multiplying with this. So you can even put a dot there if you want. So we have 2 different functions separated with a multiplication table. So remember, we said to get the derivative, the first step is let u be equal to the first function, which is 2x squared. 2x squared. And you let v be equal to the second function, which is 4x minus 1. And remember, the formula for getting the derivative of this is y prime, which is the same as dy dx, is equal to u prime v plus u v prime. So it is the derivative of u times v plus u times the derivative of v. That's what we're doing. So on a separate piece of paper, we can get the derivatives. So from the u equation, we have u is equal to 2x squared. Okay. So to get u prime, which is just the derivative of this, we're multiplying the power times the coefficient. So 2 times 2. 2 times 2 minus 1. So u prime is equal to 2 times 2, 4x. 2 minus 1 is just 1. So this looks like a y, sorry. 2 minus 1 is just 1. So you know that x to the power 1 is just the same as x. So this is our u prime. That's our u prime. So we can replace it here in this equation. So y prime is equal to u prime is 4x, open bracket, it's multiplying with the v equation, which is this. So v is equal to 4x minus 1. Then plus, so we can now come to this part. So this part says u v prime. So we get the u function, which is just 2x squared. So 2x squared is being multiplied with the derivative of v. So you know that v is equal to 4x minus 1. So v is equal to, v prime, which is just the derivative of this. So x is the same as x to the power 1. So we're multiplying the power times the coefficient. 1 times 4. X, the power reduces by 1. 1 minus 1. Minus 1 is a constant, and the derivative of a constant is always 0. Okay. So v prime is equal to 1 times 4, that's 4. X to the power 1 minus 1 is 0. Anything to the power 0 is equal to 1. So this is the same as multiplying 4 times 1. I hope this is not confusing here. So v prime is just equal to 4. So we can even put our 4 there. Having this, let me erase this so that we have more room for our calculations. I hope you're not lost so far. Hope we are still together. Okay. So u prime is equal to, we're going to multiply this with all these terms in here and this with that. So 4x times 4x will be 16x squared. 4x times 1 will be minus 4x plus 2x squared times 8 will be 8x squared. Let me write that squared properly. Okay, so I've simply expanded this. So y prime is equal to, we can collect the like terms. So 16x squared plus 8x squared minus 4x. So y prime is equal to 16 plus 8, that's 24x squared minus 4x. So this is our answer. Although if you want, you can go on to factorize it, but I'll just end here. So that's for the product rule. The product rule. Sorry. Oh, I think I erased the name of the... So that's the third rule. Okay, so the next rule we're going to look at is the quotient rule. So that's the fourth rule. Okay. So, 4, we have the quotient rule. My markers are slowly dying on me. Okay. The quotient rule. Is that clear? Okay. Yeah. So the next rule is the quotient rule. So with the quotient rule, you might have an equation such as y is equal to f of x over g of x. So you basically have two different functions that are being divided. So in such a scenario, again, you can use the same method where you say let u be equal to f of x and v be equal to g of x. For me, this really makes my work easier, makes it easier to deal with everything. Okay, so having this, the formula now is y prime, which just simply means dy dx. Again, I'm not about to speak French. It is still English. Okay, so y prime is equal to u prime v minus u v prime over v squared. So that's what we have. So for this part, remember the u prime is just simply the derivative of the u equation. The v prime is just the derivative of the v equation. And v squared is just all this being squared. So this is the formula. So having the formula, we can now get to the calculations. So let's use numbers now to make our work easy. So we are now using numbers. So y is equal to, let's say, 3x plus 1 over 2x squared minus 3. So this is our equation, okay? So in order to find the derivative of this, we are going to let u be equal to 3x plus 1, 3x plus 1. So that's just 3x plus 1 in case it's not very visible. And v be equal to 2x squared minus 3. This is 2x squared minus 3. And we know that our formula is y prime, okay, let me say dy dx. Dy dx is equal to u prime v minus u v prime over v squared. So dy dx is equal to, so u prime v, so from our u equation, u is equal to 3x plus 1. So this is our u equation. So from this 3x plus 1, to get the derivative, so we know that x is the same as x to the power 1. So u prime is equal to the power times the coefficient. So that's 1 times 3, which is just 3x. The power reduces by 1, so 1 minus 1, which would be 0. So this is x to the power 0. And you know that any number to the power 0 is just 1. So it's the same as having a 1 here. So that's 3 times 1 plus, this is a constant. And you know that the derivative of a constant is 0. So this is just 3 plus 0. So u prime is just equal to 3. I hope I wasn't too fast. I just multiplied the power times the coefficient, and the power reduced by 1. And the derivative of a constant is 0. So that's the 3. I hope I'm not too fast. Okay. So u prime is 3. So 3 is being multiplied with the v equation, which is 2x squared minus 3. So then minus u, just a minute, minus u, which is this equation, 3x plus 1, which is being multiplied with v prime. So to get v prime, our v equation is v is equal to 2x squared minus 3. So v is equal to, v prime is equal to, so multiplying the power times the coefficient times 2, which will give us 4x. The power reduces by 1, so that's 2 minus 1, which is just 1. And remember, the derivative of a constant is 0. X to the power 1 is just the same as x. So v prime is just equal to 4x. So where we have v prime here, we're going to replace it with 4x. So again, I hope I'm not too fast. Okay. So we divide all this by v squared. So that's 2x squared minus 3 squared. And we can expand the top part. dy dx is equal to 3 times 2x, that's 6x. Okay. 3 times, this is 2x squared, so that's 6x squared minus 3 times 3, that's 9, minus, please, brackets are very important because unlike the plus sign, a minus is really going to affect all this. So 4x times 3x, so this would be 12x squared plus 4x times 1 is just 4x over v squared, which is 2x to the power 2 minus 3 squared. So that's what we have here. Okay, I'm afraid if I write down, you won't be able to see what I'm writing. So let me just quickly erase this top part. That's how I'll write the final answer. So I hope you followed so that you don't get lost after I erase this. Okay. A minute. Okay. So then dy dx is equal to, so we have 6x squared minus 9. Then we have a minus sign here. So this sign will multiply with everything. So minus times 12x squared. So this will be minus 12x squared. The minus times this positive 4x will be minus 4x over v squared, which is just, just a minute, which is just 2x to the power 2 minus 3 squared. So I hope we're together so far so that you don't get confused when I erase something. Okay. So we can now deal with the like terms. So dy dx is equal to, so we have 6x squared minus 12x squared. So we have a big number subtracting a small number, so the answer will be negative. So the answer is negative 6x squared. And we have a 4x, okay, so minus 4x. And we also have a 9, so that's minus 9 over 2x squared minus 3 squared. So this is our answer. So if you want, you can factorize this. If you want, you can end here. There's no problem. This is your final answer. So this is our final answer. So that's on the quotient rule. I hope we are clear on the quotient rule. Okay, so the fifth rule, I hope you're not yet tired. We only have 3 more rules to go. Okay. So the fifth rule is the chain rule. So that's number 5. Chain rule. Okay, so this rule is for equations that look a little something like this. Y is equal to 2x 2x squared minus 1 to the power 6 for such an equation. So I'm sure you agree with me to say if we wanted to expand this, it would take a lot of time. So that's why we use the chain rule. Of course, if you want to expand it, if you've got the time, please, you will get the same answer when you expand this. Okay, of course, but you have to factorize it at some point to take it to its simplest term. But if we're to expand this, it will take a lot of time. So with the chain rule, okay, we're going to say let u be equal to 2x squared minus 1. So I hope you're following. I'm going to try to say this as slowly as I can. Okay, so I've just let u be equal to this function. Okay, just the function without the power. Okay. So if we say u is equal to this, meaning therefore y will be equal to u to the power 6, right? So since we've said let u be equal to 2x minus 1, which is this, so we've just replace this whole function with u. That's this. Okay. So with the chain rule, to get the derivative of this, to get your dy dx. So dy dx is simply equal to dy du times du dx. This is the formula. This is the chain rule formula. Dy dx is equal to dy du times du dx. And from our basic mathematics, if we're to divide this, we can just simply cancel out the du there and the du there, and we just remain with. Okay, let me just show what I'm saying, because I'm also confusing myself anyway. Okay, so dy du times du dx. So to get dy dx, we're going to get first dy du times du dx. So from our y equation, we have y is equal to, so let me write it this side, y is equal to u to the power 6. So to get dy du, we're simply multiplying the power times the coefficient, and the coefficient here is 1. So 6 times 1 is just 6 times u, the power reduced by 1. So that's 6 minus 1. So this is equal to 6u to the power 5. So that's what we replace here. 6u to the power 5 times, okay, so let me quickly erase this. And, and to get du dx, so du dx will be equal to, so our u equation is u is equal to 2x squared minus 1. So du dx, we're going to differentiate this. So 2 times 2, that's 4x. 2 minus 1 is just 1, which is just the same as 4x. So this is times 4x. I hope I'm not too fast. I'm just simply multiplying the power and the coefficient, and the power reduces by 1. Okay. So that's our du dx. So now we can come to our dy dx. We're multiplying these two. So dy dx is equal to, we can multiply this 6 with the 4x. So 6 times 4, that's 24x u to the power 5. Okay, so let me just erase part of the top part so that you can see. Which part will I erase? I hope you've copied the formula. So I just erase this part. Okay. So I hope you remember that we let u be equal to this. Okay. So please don't forget that. So from here we have dy dx is equal to 24x u to the power 5. So let me just write it on top. So dy dx is equal to 24x u to the power 5. And remember, we said in the beginning, we said let u be equal to 2x squared minus 1. So dy dx is equal to 24. Let me just, is equal to 24x. Where there is u, we replace this function. So that's 2x squared minus 1 to the power 5. That's our answer. So that's the chain rule. So you simply it doesn't always have to be u, you can use any letter. So we simply let u be equal to this, and we said y is equal to u to the power 6, and we got our dy over dx by multiplying dy over du times du over dx. Hence, and afterwards we replaced the u, we brought back this equation where the u is to get this. So I hope that's clear. Okay, so we have, okay, let me write this because it looks too scrappy. So let me just erase it and write it properly. So we have 20, sorry, let me get, okay. We have 24x, open bracket, 2x 2 to the power 2 minus 1, close bracket, to the power 5. And that's how we get, that's the chain rule. So I hope we're clear on the chain rule. Okay. So the next rule we're going to look at is the logarithmic rule. That's the 60th rule. So number 6, logarithmic rule. So with the logarithmic rule, from the word logs, of course, okay. So you might have an equation such as in the form y is equal to, in x, okay, let me use f of x, let me use a function, in f of x, okay. So you have an equation in that form. So to get the derivative, so dy dx or y prime is equal to, so this will be equal to the derivative, so f prime of x, which is just the derivative of this function, over the whole function. Repeat the function. I hope that's clear. The derivative of the function over the function itself. So let's use numbers. Okay. So let's say we have y is equal to, in 3x plus 1. And remember we said dy dx, sorry, my markers are becoming really faint, but hopefully you can get what I'm saying. So dy dx is equal to, remember we said it's equal to the derivative of the function over the entire function itself. So this is equal to the derivative of the function over the function itself. So I was just trying to remind you. Okay, so the derivative of this function, we have 3x plus 1. To differentiate this will be equal to, the power there is 1, so 3x, 1 minus 1, that's just 0, so you just have a 3. Derivative of a constant is just 0. So the derivative of this function is 3. I hope I'm not too fast. Okay. So the derivative of this function will be on top, to be our numerator, so which is 3 over the function itself. So that's 3x plus 1. Simple, right? Just a little practice and it will be so simple. So that's with the logarithmic function. So dy dx is equal to the derivative of the function over the whole function itself. So that's for the logarithmic function, okay? So this is just equal to 6x. So the derivative is 6x. Let me erase this. So 6x times, repeating the function itself, e to the power 3x to the power 2 plus 1. So that's how you get the derivative of the exponential. That's how you get the derivative in an exponential rule. You simply get the derivative of the function, which is this, times you repeat the function. That's all you do. Okay, that's all I had in this video. I hope you enjoyed it. Please don't forget to subscribe. If you found the video helpful, please like it and leave me a comment on what else you would like me to explain. Thank you for watching, and bye-bye.